Hereby, I open this academic ceremony in which Yicong Lin will defend the academic thesis essays on non-stationary, nonlinear time series models. May I invite you to present a summary of your study and the conclusions of your thesis. The floor is yours.
Thank you, Director. Now I'll start sharing my screen. Can you all see my screen now? Is it okay?
Yeah.
Okay, perfect. Dear Director, dear members of the Corona, dear family, friends, and audience, thank you for joining my PhD defense, and many thanks to those who feel more nervous than myself, making me more even nervous, as if I'm receiving the Nobel Prize winner today. In the next 15 minutes, I'll briefly introduce my thesis. The presentation is organized as follows. First, I will talk about what is a thesis about. I will give my reasons why I think the problems are important, and I will give my solutions, and using the proposed methods, I will make the conclusions. Finally, I will also talk about what I have not concluded, but I wish to explore in the future. My thesis is best motivated by the following two examples. The figure on the left-hand side is for chapter 2, and the figure on the right-hand side is for chapters 3 and 4. Now I'll give more details about these two figures. The first example is about total factor productivity. In the figure, the vertical axis represents the total factor productivity of the Netherlands. And the horizontal axis represents or indicates the years. And what is total factor productivity? Total factor productivity is a measure of productivity growth, which is not due to capital and labor input, and is often considered as a measure of technological innovation. Looking at the curve, we can see there are simply two phases. It steadily increases until the year around 1978 and becomes more slowly after that. Economists have debates about this. Some economists think such transition occurs slowly, but the others think such changes are abrupt, maybe due to some external events, such as the energy crisis in 1970s. But in general, for the latter, we often do not know which external events they are, and therefore also do not know when the changes actually occur. So my first question is, can we find the timings of changes? Now I move on to the next example. The second example is about the relation between air pollution and economic growth. In the figure, the y-axis, so the vertical axis here represents the carbon dioxide emissions in Belgium, and the horizontal axis represents log GDP per capita. We can see there is an initial increase in air pollution as GDP increases, and there's a turning point after the GDP arriving at a certain level. Such inverted U-shaped relation between per capita income and air pollution is nowadays summarized as the environmental goods-net curve hypothesis. My second question is, can we somehow test if the EKC, so the environmental goods-net curve hypothesis, is true or not? Further, I would like to ask that is the GDP per capita the only driver of the change of carbon dioxide emissions? For instance, if we recolor the points on the plot, according to the time, we can see there is the air pollution increases in the early stage and decreases in more recent years. Therefore, air pollution and per capita income also have an inverted U-shaped relation. Which factor drives the change of carbon dioxide emission? the GDP or some factors that might be represented by time, for instance, like environmental awareness or environmental control policy. So far, I have introduced my research questions. Now I'll give the reasons why I think these problems are important. For the first example, recall that we would like to find the timings of changes. The reason is the timings of changes help us to pin down the link between variables and potential events. Generally speaking, a more accurate timing gives more accurate or more convincing links. Furthermore, inferences about economic relationships, forecasts, and policy recommendations can be very misleading if one simply just ignores the changes. For the second example, let's first think about what can be implied if the evidence of EKC is found. It implies that the turning point will eventually emerge if per capita income is high enough. Therefore, we can simply just adopt a growing now, cleaning later strategy and without worrying the environment at this stage. However, what if the evidence is false? If it is false, such development strategy may bring us irreversible harm to the climate system of Earth. For this reason, I think a critical evaluation of the EKC can never be overemphasized. How to tackle the problems? In chapter 2, we use two straight lines to approximate or to capture the transition. So look like this. Then we propose an efficient method to pin down the change location. The efficient here means we can find out the change location more accurately with the same amount of data. Note that the data is random. The location estimate is also random. To quantify the uncertainty, we further propose methods to tell statements like the true location stays in a certain range with probability 95%. And the range here is between 1974 and 1981. In chapter 3, we adopt a commonly used model in literature, which describes the carbon dioxide emissions as a quadratic function of GDP. But instead of looking at countries separately, to capture the underlying dependence over time and across countries, we model all the, not all, but the multiple countries jointly. Then we propose a new method to estimate the unknown parameters. And to study the EKC, we propose tests to see if the parameter C equals to 0 or not. Because if C is 0, then there's no U-shaped relation between carbon dioxide emission and GDP. In chapter 4, we additionally use some function of time to represent potential drivers other than GDP. And similarly, we would like to test if the parameter C equals to 0 or not for the EKC study. To this end, we propose a simulation-based method to test if C equals to 0 or not. And using this method, I obtained the following conclusions. We evaluate statements like the true change location is in a certain range with probability 95% using computer simulations. And we find such statements are reliable in many cases. We also find that taking dependence into account improves the performance of parameter estimations and hypothesis tests in many cases, not necessarily to be all. We also find if one ignores time effects, the probability of making false discoveries of the EKC can be high. And using a very specific data set, we also find the decline of carbon dioxide emissions is most likely due to omitted variables other than GDP. What have I not concluded? Wow, everything that was not mentioned before belongs to this class. But more specifically, I want to mention that the method in chapter 2 hinges on somewhat more restrictive assumptions. And I'm still wondering whether we can extend the framework to allow further flexibility. And we also notice that it is very difficult to fully distinguish time effects from GDP. And now we're currently extending the model to account for time effects. But breaking down the sources of time factors is still remains on our research agenda. It's quite difficult because there are many issues to take into account. Of course, there are still many. And thank you for your listening. Now I'll give the word back to the prorector.
Thank you very much for your short but concise presentation. The opposition will be opened by Professor Dr. Alain Heck. Professor Heck was the chair of the assessment committee, and Professor Heck is a professor of applied econometrics at this university. The floor is to Professor Heck.
So dear candidate, dear Yicong, dear wise men, as you wrote in your acknowledgement, I would like to congratulate you for the very technical 3 chapters that you have done. And you refer to Jean-Pierre. I think that Jean-Pierre would be very impressed and proud of you as well.
Please lower the microphone a bit.
You hear me better?
Yes, better.
Yes, I should apologize, but the mic of my computer is broken. I mean, I have to use this way. I use this one.
The headset touching your beard.
I don't have time to shave myself. Let's try like this.
Yeah.
Yes.
Much better.
Okay. So then you heard that I had congratulated you about your work. I read yesterday your acknowledgement, and it was, I mean, because you didn't put it in the text before, of course. I was wondering, but it's not a question. You translate more than smart by wise men, and you said is a bound. I was wondering before sleeping yesterday, is it a lower or upper bound in your traduction? But I mean translation. But anyway, just to say that I slept on your thesis yesterday evening. I have two small questions. Mm-hmm. The first one is about the total factor productivity graph that you have shown in your thesis in page 4 and the main investigation of your chapter 2. My students in time series, they work with similar data for the US, not for the Netherlands. And they found that there are 2 breaks in this data. That means one around your period and a second one around the financial crisis, say 2008-9, and you see you could have a different slope for the trend. And my first question is, would it be possible to easily extend your method to find more than one break, or is it trivial or not? My second question is, I have to refer papers and they use tapering methods. It's not intuitive to me. I mean, I have a hard time to understand what tapering means. Basically, you kick out some variable and you try and it improves the story. You mentioned several times that your tapering doesn't work that your methods to work directly with the inverse of sigma is better than to use tapering methods, for instance. Can you explain me why tapering that the papers I read, they say it's wonderful, wouldn't work, and that your method is that you propose is more appropriate? These are my 2 questions.
Thank you. Dear highly esteemed opponent, thank you for very nice words. Let me try to answer your two questions. First, you mentioned that whether I could extend my methods to find more than one structural breaks. I think of course we can. There's one typical issue is in trend break model, which is we kind of need the assumption of the number of structural breaks, because let's say if we have a number of structural breaks which is 5, but we estimate the structural breaks, let's say 2, and I think there's a paper shows that typically we don't have consistency result. And I think it's quite difficult for a trend break model here. So indeed, in the US data, I also recall from a paper by Bruce Hansen, and he also find there are multiple breaks in the data, and there's one quite in a recent year. And now let me go to the second question. And why is tapering technique is not fully appropriate here? If I remember correctly, the tapering technique indeed allow us to estimate the covariance matrix. But here for GLS, we typically need the inverse covariance matrix. Of course, we can use tapering to estimate covariance matrix and take the inverse. But there's also difficulty in the literature, which is we often do not, it is very difficult to guarantee positive definites by just estimating the covariance matrix itself. I remember there's a paper by Wu and Puramadi. They have certain technique to carefully choose the tapering bandwidth to guarantee the positive definites. But there is also a bit tricky because the bandwidth depends on many factors, and of course it's quite difficult to use. And we also do not know the theoretical property by using such inverse covariance matrix. And in our case, I think it is nice because the inverse covariance matrix give us a very straightforward explanation of GLS. So it's basically just filtering and scaling in our case. So I think that's the advantage of our method. I hope I answer your questions.
You did. Thanks, Yicong.
Thank you.
Thank you. The opposition will be continued by Professor Robert Taylor, who was a member of the assessment committee, and Professor Taylor is a professor of financial econometrics at the University of Essex. The floor goes to Professor Taylor.
Thank you, Pro-Rector. Good morning, and I'd like to congratulate you on your thesis. It's an excellent piece of work, and I enjoyed reading it. But as with all academic work, when we read things, even if we enjoy them, we disagree with some things and have questions we might like to ask. So what I'm going to do is ask you 3 questions. I'll ask them in a row to give you the opportunity to answer them as briefly or at length as you want for each individual one. So the first question is, in your thesis, 2 lines under your equation 2.2, you say that the dependence, which is in epsilon t in that equation, can also be strong dependence, as we see in macroeconomic series. But then in assumption 2.3, you impose a condition of weak stationarity. So of course, that does not allow for strong dependence. Also, your assumption does not allow for any conditional heteroscedasticity in the shocks driving the model, or any unconditional heteroscedasticity. So the question would be, how useful do you think that is? And do you think you can extend those things to allow for things like near unit roots and heteroscedasticity? And then as such, how appropriate are the methods for the data you're applying them to, given those restrictions your theory imposes? The second question is that I'm not entirely sure how useful your results are for inference, because you have to assume that the break sizes on the level and slope can't be simultaneously 0. So given they're also assumed to occur at exactly the same point in time, that logically means you're assuming that it's known that a break must occur. Now that is a very strong assumption. Why would I know that a break definitely occurs? So even if I go with your setup and I make do with your assumption, which should I test first, of the level break being 0 or the trend break being 0? If I test one of them, I have to assume the other one is 0, So logically, it would then never make sense to test the second one. So given those results, can you give me some thoughts about how you would test in practice whether a break actually occurs? And if you think it does, how would you actually test whether it was a level or a trend break? And then finally, it's argued in your conclusions that the feasible GLS method improves estimation accuracy. But then, of course, your result in section 2.3.2 shows that GLS, OLS, and quasi-differencing are asymptotically equivalent. So your asymptotic theory is not enabling you to make that statement. Presumably then it's based on your Monte Carlo, but Monte Carlo is always, of course, limited to the DGPs you analyze, and they're a finite set. So proposition one, maybe, could you look at higher order terms, which might be able to then give you differences in the limiting distributions and actually justify claiming efficiency? That's it.
Dear highly esteemed opponent, thank you for enjoying reading my thesis. Thank you for super intelligent questions. First, about strong dependence, the assumption in my thesis. First, my method, so I indeed assume weak dependence in the thesis. That's for theory, but I can see the extension or the possibility of extending the method to allow strong dependence and including nearly uniroot and let's say also long memory processes. I think that's possible because there's already papers on about how to estimate the inverse covariance matrix under these situations. Typically, I was also thinking about heteroscedasticity in the data, and currently, so our setup do not allow both conditional and unconditional heteroscedasticity. But I think there's a way out. So what I could imagine is, because GLS is nothing just doing filtering and rescaling. So what I would expect is, suppose there's a zero dependence, what I could do is I would just first do the filtering and rescale the time series. If there's I'm not sure about conditional heteroscedasticity, but for unconditional ones, I think we could also estimate the variance function, I guess, using probably some non-parametric methods should be possible to do that. And we use this estimate to rescale the data, to rescale the model. And I think GLS should work there. I'm not entirely sure about the symptotic theory for trend breaks models. And the second question is about my restrictive assumption about so I cannot allow, or I have to assume there's a structural break, right? And indeed, I totally agree. So in our current setting, we kind of assume there's a priori information saying structural break must occur. Indeed, this is not very natural in practice. And of course, we should somehow think of a test to see if there is or the existence of structural breaks or not. And I think for trend break models, I'm not entirely sure whether there is certain method to test for structural breaks, should be, I guess. But for a level break model, I'm pretty sure there are many structural break tests to test for existence. So I think this is also doable. So it's more like we first do a test for existence, and then we use, if it exists, then we subsequently use the method proposed in the thesis. But of course, here is also a bit tricky because it is involved with conditional inference. And I'm not entirely sure whether, of course, in practice, we always do this, but I'm not entirely sure in theory as well. And third, about symptotic equivalence. Indeed, I totally agree. My statement was too strong in my slides, but I've also mentioned that in what I have concluded, which is I say, partly I've mentioned that we improve the parameter estimation and and also test only in many cases, but not all cases. So it's more like a final sample evidence. And of course, because of the asymptotic equivalence, we cannot really say much. And I've never thought about higher order asymptotics, but that for sure would be something very interesting to explore in the future. That would be very interesting if we could find out efficient or asymptotic efficiency using a more advanced asymptotic theory, and for sure that would be something interesting to explore about in the future. Thank you. I hope I answered your questions.
Yes, thank you. So I hope you therefore appreciate the logical inconsistency of a setup where you say, I definitely know there's a break, but I don't know where it is. Because as soon as you definitely know where there's a break, you really should definitely know where it is, at which point estimating where it is becomes slightly logically irrelevant. I think I'm done on my questions. Thank you very much.
Okay.
Thank you.
Good answers. Thank you.
The opposition will be continued by Professor Christoph Henk, who is a professor who was also a member of the assessment committee and who is professor of econometrics at the University of Duisburg, Essen. And the floor is to Professor Henk.
Okay, Prorector, thank you. Let me join the predecessors in thanking you for giving me the opportunity to read a very competently executed and interesting thesis. Prorector, allow me also to drop my first question that we had agreed upon in view of Rob Taylor's question. I think there is enough overlap to drop it and modify my list slightly. I'd have questions on also the trend break chapter. In particular, you construct confidence intervals based on likelihood ratio tests, which you argue will be narrower than LBI-based ones. And I was wondering if you can give me some intuition on why that is. Next to that, I was wondering about possible generalizations of the setup. So currently, the model has an intercept and a trend, possible or broken ones, as we saw in the previous question. Can you generalize that to setups where you also include further regressors? And finally, a more specific one maybe, you in equations 234 and 36 propose confidence intervals which are based on confidence intervals which, as far as I understood, are argued to be valid, which are then in the first example and in the first case taken or as a union with another quantity, and in the second case intersected with another quantity. And in the first case, I would intuitively expect this to lead to additional coverage, so to broader confidence intervals if you take a union, and in the second example, when you take an intersection, to possibly narrower ones. And I was wondering whether that has any implications for the coverage of the confidence intervals, or then again, maybe not asymptotically, because this union and intersection doesn't matter in large samples. Thank you.
Dear highly esteemed opponent, thank you for your questions. And I think they're indeed very relevant. First, you have mentioned about the confidence interval using likelihood ratio tests to construct confidence intervals, and why. So what is the intuition why we should have more or narrower length of the confidence sets? And my intuition is given as follows. So I think constructing tests or constructing likelihood ratio tests give us better power in the test. And therefore, if you have a much better or much powerful test, I would expect also the confidence set will be shorter. And there's also a test mentioned in the paper or in the thesis. There's a locally best invariant test. And for that test, indeed, it performs super good in terms of size. However, I think there's some power issue, and I think it's what it calls a non-monotonicity problem there. So basically, if you increases the bridge sizes, you don't really gain power, or it depends, but you don't gain much power. And therefore, they always have quite long confidence intervals. So that's my intuition about why the likelihood ratio tests based confidence interval should give better confidence length. And the second question is about whether we could include other regressors. Indeed, yes, that will be possible. Here we focus on the trend break because in practice or based on my knowledge, so like for instance, the paper by Perron on econometric 1989. So what they are, or also like, so there's a debate about whether macroeconomic theories are random walks or transstationary, etc. And there they always just focus on trend break model because they want to know whether the series are random walks or not. And here, so we adopt similar strategy because of this. But of course, we could include other regressors, but also depends on which kind of regressors you want to include. If the regressors are stationary, I don't think there are any difficulty in terms of theory. If it is non-stationary, I'm not entirely sure yet. I think it would be possible because it is quite similar with just co-integrating polynomial regression. So it should be doable. And for this last question about I think you asked about the what-based or what test-based confidence interval, which is so equation 2.36, right? And okay. So the main issue of what-based confidence interval is the what statistic or the what test performs super bad or not super bad, but the approximation is super bad. So that's why the what test. I think the main problem of the what test based confidence interval is the size issue. So I don't think I'm not entirely sure about the intuition about the length, but I think the main problem of what test is the size problem. I'm not sure whether I have answered your questions or.
Yes, thank you.
Okay, thank you.
Thank you. The opposition will be continued by Dr. Ines Willems. She was the last member of the assessment committee, and she's an assistant professor in quantitative economics at this university. The floor is to Dr. Willems.
Okay, thank you. So, dear candidates, dear Yicong, let me also start by congratulating you on a very nice piece of work. I enjoyed reading your thesis, and it really offers difficult theoretical contributions, but I also appreciated the focus on, for instance, the environmental Kuznets curve, where you bring in a more applied perspective to the thesis as well. My question for you today, the first one is a very general one, and concerns the approach that you took to handle nonlinearity compared to, let's say, alternative approaches. So, as you know, there has been a large literature in econometrics on handling nonlinearity, and that ranges from models that require us to specify the kind of nonlinearity we expect towards, let's say, maybe more modern methods that let the data decide, if you wish, on the type of nonlinearity that is most suited, let's say. And in the introduction, you also mentioned, for instance, some of these alternatives like machine learning methods, boosting, or neural networks. So could you explain us a bit more elaborately, let's say, your preference here? And so could you discuss advantages and disadvantages you see for the approach that you take to handle nonlinearity compared to alternative methods? So thank you.
Dear esteemed opponent, very good question. Let me think about alternatives way to model nonlinearity. Indeed, there are lots of methods to do that. Of course, for instance, we can adopt non-parametric method or semi-parametric method, or we can use machine learning techniques to do estimations, etc. And there are indeed many possibilities. Here is, I think, our papers are more focused on the study of the EKC. Indeed, we can adopt very general parametric or non-parametric models to study the problem, but there is kind of against our or our focus, let's say. So because we focus on the EKC and what we like to find whether there's evidence of the EKC. Suppose, let's say we adopt a very general model, let's say it's non-parametric model, and YT is just a function of ST, and we don't know what is the function of it is. And in the spirit of Phillips, the paper on Econometrica 1998, if the function is general enough, we can always approximate a non-stationary process YT by ST. So we may end up with an spurious regression framework. So there, we also need to think about, because theoretically speaking, I don't think there are many difficulties for both non-parametric or parametric framework. I'm not entirely sure about machine learning techniques there, but it's not really we want to use to study the EKC. I do know there's a paper, I think it was published several years ago on Journal of Econometrics by some Chinese guys. And what they do, they have a double nonlinear co-integration model. Basically, on the left-hand side of the model, it is a parametric parametric model, a parametric function of YT. And on the right-hand side, I think it is a non-parametric or an unknown function of ST. And they use this model to study the EKC. But I think I really have doubts about this kind of model specification. But I do think there are some possibilities in the future to study study other models for nonlinearity. For instance, what I'm considering now is we use a semi-parametric model, which is YT equals ST times a function. So beta is a function of the time point. So it's beta T. So and we look for some ways to estimate and also do inference for the beta function. And there's a paper recently just published on Journal of Econometrics by Li, Phillips, and Gao, and they studied this model for nonlinear co-integration. And there they find very interesting results, especially in terms of theory, and it's highly non-standard. And but I think there's still quite some room to do about pointwise and uniform inference about this type of model in nonlinear co-integration literature. And further, of course, we can think about if we could use some like neural network or some machine learning techniques to study nonlinear models. I'm not entirely sure whether it fits to the EKC literature or not, but that would be for sure possible. But I also think, theoretically speaking, it's also difficult to manage. And I would be happy to try something there as well. Thanks. I hope I answer your questions.
Yeah, thank you.
Thank you.
Thank you. The opposition will be continued by Professor André Lucas, who is the Professor of Finance at the Vrije Universiteit Amsterdam. The floor is to Professor Lucas.
Thank you. Let me first agree with the previous panel members on congratulating you on a very fine piece of work, which I liked reading. My question relates to chapter 4. And in particular, you have there a range of results on the empirical Kuznets curve. And actually, I think I have 2 questions there. On page 181, which is the conclusion there, right? So you don't need to look it up. You write essentially that it's more likely that there could be time effects, essentially, than that there's an empirical Kuznets curve effect. Now, that's kind of an important empirical conclusion, of course. And my question relates to the univariate character of most of the analyses that you appear to have done there. Could you maybe explore the panel type of the panel dimension of your data set to really test whether, for example, there are differences between the technological progress with different countries and therefore differences in the empirical Kuznets curve, or whether there's different environmental awareness that could explain why there are different kinks or curvatures in this Kuznets curve, and in this way help us to really see whether it's there or whether it's not. And related to that, and also maybe a bit to the previous question, is that there's lots of flexibility in the deterministic trending pattern that you theoretically exploit. But of course, you could also still think that this quadratic form that you now include for the Kuznets curve, xt and xt squared, is a very particular one, right? Probably we would also be very unhappy as a world if right, it would level off, maybe even go a bit down, and then level off at too high a level in absolute terms for the planet to sustain it in terms of the emissions. So could you reflect a bit on either of these two, so the panel dimension and the empirical specification of the xt function?
Thank you. Dear highly esteemed opponent, both questions I've thought about them before. Actually, about the panel setting EKC, it was actually common by our two of our referees, and indeed it makes lots of things sense to think about the panel setting EKC. And it took me also quite some time to figure out the EKC study should not be a time series; it should be a panel setting. So indeed, that's what we are doing now, and we managed to extend the framework, but not really to panel, but multivariate time series. And what we found so far is, so there's a reason why we want to do that. So let me probably first explain a bit why I want to do this, because there's kind of overlaps between the time effect and also the GDP. And GDP itself kind of capture the, let's say, technological change. And currently we explain technological innovation using the time factor. So there's a kind of overlap there. So what we do now in a multivariate setting is we use the flexible trend, but only just one. It's more like a factor model. And we use this one to drive all the countries. So basically we try to discriminate this time effect globally and locally. So the flexible time trend, it drives the global changes of the Earth or of all the countries. And we use the GDP to stand for the local trend. So this local trend to kind of capture the education or the development for a specific country. And by doing that, what we found so far is using only one global time trend, just one term with same coefficient for all the countries. We immediately cancel out. We again find evidence that the ST square, so the coefficient in front of ST square, is again significantly, or we cannot reject the null hypothesis, which is 0. So basically, using just one global time trend, we again capture the changes in the air pollution. So this is what we found so far in the panel setting. And the second question was about whether we could have more flexibility in terms of the ST term. What we have tried before is we indeed do. So we have tried one thing, so which is instead of looking at ST square, we consider ST theta. So we use ST theta to first model this to consider the data, but we find very weirdly that for all the countries, or at least 16 out of 18 countries, if I remember correctly, we could not find any minimum. Basically, it means if you let the ST to be flexible, we cannot find the optimal estimator of theta. So this is one thing. So that's why we didn't pursue further. But the second reason is, as I mentioned before, is of course we can kind of allow more flexibility of in terms of the ST term, but there we are kind of like favor or believing the EKC from the outset, because once you have more flexibility of ST, the more flexibility you have, the easier to capture the changes in the carbon dioxide emissions. And we don't know how to do or how to test there, like because such model specification is kind of like favor the EKC from the outset, and it is not what we want, because we try to how to say, like, I think the EKC is quite it's a quite dangerous statement, let's say in this way. So indeed, we could do that in theory, and I can see there are many possibilities, but probably not for the EKC setting, but for other time series data.
So maybe very quick follow-up question. So if you allude to the convergence issues, and I would think of an xt and an xt squared versus an xt and an xt to the power theta, where theta is a half. I would get a kind of a similar upward shaping bending curve, which appears to be there in most of the data, which empirically would probably be hard to distinguish. Could that be the reason? But the implications will be tremendously different.
Indeed, for univariate setting, so if we only have univariate time series data, I think indeed we have this possibility. But for multivariate setting, so what the setting we're doing now is, I don't think a global time trend can capture such, like such changes for all the countries. So I think there the possibility will be much lower. Of course, theoretically speaking, maybe we should find a way to do a test or something, but so far I don't have a better idea yet.
Okay. Thank you.
Thank you.
Thank you. The floor goes to Dr. Nalan Basturk. She's an associate professor in quantitative economics at this university. The floor is yours. Don't forget to unmute.
I hope you can hear me. Yes. First of all, congratulations for your thesis. It's great to see that you came so far. I read your thesis with interest, and to be honest, with admiration to the amount of technical work you have. So it was really a nice piece of work. My questions, as you can imagine, are from the applied side, so chapters 3 and 4. I have two questions, one short, one longer. The first one is, you use different set of countries in chapters 3 and 4. I was wondering why this is the case. Then I have a longer question. This relates to your statement that potentially several factors are affecting pollution in addition to GDP. And these factors are also potentially correlated with GDP. Then you have the endogeneity issue, and then you're trying to deal with this. Now, what I see in the simulations and the application is you deal with this endogeneity with flexible trends. So the literature does it with linear trends, you extend it to flexible trends, but what kind of additional variables can really be captured with these trends? So what are your thoughts about omitted variables, how you capture it? Does your simulations really take into account all kinds of omitted variables? And in turn, how do you think that the results are affected by these decisions? Looking forward for your answer.
Thank you. Dear esteemed opponent, thank you for very kind words. First, regarding your first question, why we use different countries in two chapters. So first, our data set is the same. So we have the data set for both chapters, but we adopt different countries for chapter 3. But for chapter 4, we use all the countries. The reason is in chapter 3, because we've developed a multivariate set estimation method, so which is a fully modified GLS, and there we do not allow the number of countries to be too many. Otherwise, I would expect the estimation of the inverse covariance matrix can be quite bad. And I also think probably the test would be out of control as well. So therefore, in chapter 3, we only use 6 countries, but these 6 countries, they are also used in the papers by Wagner, Martin Wagner. So he has, I think he has a recent paper on Journal of Econometrics, the special issue. So there they adopt 6 countries. So we just followed what he used there. And for chapter 4, because we have a time series setting, and in this case, we can just study the countries separately. So therefore, we do not encounter this issue. But of course, I think it would be nice to extend our framework to allow the dimension or the cross-sectional dimension to be larger in the future. And as regard for the second question is about the augmented variables. Yes, indeed, we didn't try to break down what the time effect represent for. And I could think of like, so far we are, we're doing a new project, which is for try to do a long forecast for carbon dioxide emissions. And there, I think I could think of some factors from there. For instance, we can have like population growth or some kind of livestock farms or something to as the sources or the causes of carbon dioxide emissions. Therefore, I don't have a better answer for now. So I think indeed that's something to do in the future. So try to think about what the time or the flexible time represent for. But yes, I hope I have a better answer. But yeah.
Thanks for the honest answer. It's also nice that you're continuing to research in this direction. Thank you.
Indeed. Thank you.
Thank you. The opposition will be continued by Dr. Martin Schumann, who is an assistant professor in quantitative economics at this university. The floor goes to Dr. Schumann.
Yeah, okay, thank you very much. So first of all, I want to start with some praise. So dear candidate, a very nice thesis. I enjoyed reading it very much. So I don't have a time series background. So it's always nice for me if someone gives a little bit of intuition, so that enables me actually to understand something here. So first of all, I was about to ask like also questions about chapters 3 and 4, but I think the discussion has actually covered quite a bit of my question already. So, I mean, you just said that you're still researching variables that could explain the change in behavior that you observe, right? So in chapter 3, you sort of confirm the hypothesis, and chapter 4, you question it a bit, right? So I just had to read my own handwriting again for other questions. So, and one that is actually maybe from my understanding. So like on page 23, you give some intuition kind of, so there's, for instance, if you know that there's no level break, that gives you more efficiency. That's what you mentioned there. And you mentioned the other case that knowing that there's no trend break actually doesn't help you in terms of efficiency. However, there, I don't think you provide any intuition on that. Could you maybe provide me with some intuition on this point?
Yes, there is team opponent, and thank you for the kind words, and thank you for your question. You mentioned about the difference of the symbiotics when we only have one of the bricks. So, so the intuition there is, let me try to think. So let's say, suppose we have a data set look like something like this. So like it increases, so there's a trend. And suppose we know, there's no trend break. So basically, the data will behave very nicely just around a mean, and right. So I think there, because there's no break on, so basically there's just a fluctuation around the mean, and I think because of this we can kind of see, or we can find the break more efficiently. So we can see like how it fluctuates around the mean. However, if there's a if we do not know there's no trend break, then I think so. Basically, if you look at the data, and if the trend break is really small, and if any fluctuation around the mean or around the trend or around the breakpoint might be kind of, even though there's no trend break, right? But because we do not know this information, but it's kind of like captured as a structural break. So it's like the fluctuation around the breakpoint will be captured as a structural break. It's kind of like giving a lower probability to detect the true break date. So that's my intuition about the trend break model. But I hope I would, yeah.
No, I think it helps me already. Yeah. Okay. Thank you.
Thank you. Thank you.
Well, this concludes the first round, and it's a custom at this university that if we start the second round, that the floor first goes to those members of the review committee who come from further away, although in this virtual context, you can discuss what's further away. But anyway, I give the floor once again to Professor Taylor of the University of Essex.
Yeah, thank you. So what I'll do here is just give you a couple of suggestions for things that you might look at rather than specific questions, things you could do to follow up on the research you've done. So in your discussion of proposition 1, you talk about VT decaying to 0 faster, but of course that doesn't really make sense because you've made an assumption on VT about a specific rate. What would be more useful there might be to state the behavior of your k-hat estimator for different ranges of rate conditions on VT. What you've actually given in that assumption is the Pitman drift rate, I think. Of course, that gives well-defined limits. So you might be able to look at other bands of rates and what behavior happens in those areas. Secondly, in your section 2.4, it's not explicitly stated, you're a bit quiet about this in the discussion, but your assumption 2.4 that we just discussed on the rate condition is quietly dropped, and you are presumably then assuming you've got a fixed magnitude break. Now, of course, the methods won't work under assumption 2.4 because you can't consistently estimate where the break occurs under a Pitman drift magnitude, but there are magnitudes that are not fixed and are shrinking to 0 that are not as fast, are not going to 0 as quickly as a Pitman rate, where you can consistently estimate the break date. So you may be able to say a little bit more there about, again, ranges of rates on your VT such that you can make sort of inferential statements and distributional statements and so on. That was basically all my follow-up. Just suggestions for further research, really. You don't require answers now.
Thank you very much. Thank you very much.
Okay, I'm happy to give the floor to Professor Hank from Professor of Econometrics of the University of Duisburg-Essen, if you would still have an issue or question that you would like to raise.
Thank you. I do. I'd have a question on the co-integration chapter, and well, very much in keeping with the remainder of the literature, your work on nonlinear co-integration is like firmly grounded in a single equation framework. I was wondering already before reading your thesis, actually, if there is scope for also adopting in a Johansen type approach, a system-based approach allowing for nonlinearity. Well, maybe it does, and I'm not aware of it, but I was wondering about your thoughts, whether it's feasible, and if so, interesting.
They're a highly STEAM opponent. So I was thinking if we go for Johansen framework, there might be one difficulty. I'm not, because probably I don't know all the literature. I think there probably could not really handle nonlinearity, I guess. So there probably we could only, because we have a system and YT and ST, we could model them together. But I'm not sure for, let's say, if you want to do nonlinear co-integration, let's say if we conclude a ST square term in the system, I'm not entirely sure how to do this at this point. And especially there is like, how can we explain, or how to really define co-integration or nonlinear co-integration? I think it's a bit tricky. I'm not sure whether there are any literature discussing this Johansen framework to allow more general functions of ST. But
asked.
Yeah, so
yeah, we conclude your response. Please go ahead.
Yeah, so yeah, please. I will briefly conclude. So I'm not sure whether there's a way to do this or not. That's it.
Okay.
Thanks.
Yicong Lin, the time appointed for defending your thesis has passed. and the degree committee will now withdraw to discuss the quality of your thesis and the quality of your defense. And I request that you and your company await the results of our deliberations and our return. Yicong Lin. The degree committee here present online has assessed the quality of your thesis and the quality of your defense, and in view of its positive verdict and taking into account your previous qualifications, the degree committee has decided to grant you the degree of doctor. Dr. Smekers is authorized to confer upon you this academic distinction in accordance with Dutch university custom, and I invite your supervisor to now take the floor. Dr. Smekers.
Dear Yicong, do you promise to work in accordance with the principles of scientific integrity at all times, to be careful and honest, transparent, independent, and responsible?
Yes, I promise.
By the authority vested in us by law and in conformity with the decision of the committee here present online, I hereby confer upon you, Yicong Lin, the degree of doctor and grant you all rights attached by custom and law. As evidence of this, you will soon receive the degree certificate signed by the rector, the secretary, and the supervisor, affixed with the official seal of the university, shown by the beadle.
Wonderful.
Thanks.
Dear Yicong, I think a big congratulations are in order that you reached the end of this road. Well, it's only the beginning, of course, of your career. It has been a big ride, and let me take you back to when I first met you, when you were doing your research master. You came from China to do the research master here. Being equipped with a background in mathematics, so we took notice of you early on as someone who might be interested in doing econometrics. And I think it was really Jean-Pierre that actually brought you to econometrics and got you excited to do your PhD on that. I mean, already as a student, you really stood out. You were a member of the winning team from Maastricht University of the econometric game. And Jean-Pierre and I were very happy that you wanted to write your master thesis with us and then also continue your PhD. And I think your master thesis already says a lot about the way you are and how you do research. The idea was to write it about structural breaks, which was, of course, also part of your PhD thesis. Now, what became very clear to us very early on was your work ethic. You worked extremely hard, and you were very excited and interested in doing particular theoretical work. You were interested in everything related to theory. And it went much beyond structural breaks. So let me just, for fun, I looked up the keywords that you listed in your master thesis, which was about structural breaks. And so the keywords were weak convergence, weak topology, Riesz representation theorem, dual spaces, invariance principle, residual bootstrap, sieve bootstrap, relative compactness, tightness, structural break, there it is, and Hayek and Renyi inequality. So I think it's pretty clear that your interest already back then went much beyond that, and as soon as you could look into asymptotic theory, you were so excited and really loved to work on that. And in the end, your thesis was 140 pages of math derivations, even finding mistakes in published papers and correcting these. And well, that was a great start towards your PhD. And I think you continued this line in your PhD. And of course, I mean, the beginning of your PhD in particular was very difficult when Jean-Pierre was your big inspiration, passed away. You dealt with that remarkably well. Of course, it helped a lot that Erik stepped in as supervisor, and the three of us continued your PhD in that way. And well, I remember all the many meetings we had, lots of whiteboard discussions, counterexamples on the whiteboard, your derivations on the iPad during the meetings, and of course your mug, your thermos mug, which was present at every meeting we had. And these meetings were always very pleasant, and I think always were in a very good spirits. And I very much enjoyed our our collaboration there. And of course, another thing that was also always present was your shorts, which you prefer to wear throughout the year. Not really fond of hot summers in my hot office on the third floor. So that was always, we always had a lot of fun, I think, in these meetings. I think you were known to everyone, not just to us, as being very friendly, kind person, humble, and someone you can always go to for advice and discussion. And then I think that your fellow PhD students, but also your regular students, have also always really appreciated that. I mean, just to highlight your teaching, where you always, when you had to teach difficult mathematical subjects to bachelor students, you always went way beyond what you should do, having open office hours, making recaps in tutorials, even writing blog posts about probability for your students. And they really appreciated that. I mean, the reviews that you got after teaching always highlighted what a wonderful teacher you are. So your PhD started with structural breaks, and at some point you shifted a bit. I mean, not that much, because you still like to do time series and theory, asymptotic theory. And then you started working with Hanno on more co-integration, nonlinear co-integration, things for your other two chapters. And I mean, I think that even though there is a break going from structural breaks to that, there was also no break in terms of how you approach these topics and the kind of work with all the proofs and derivations you like to do. So I think that is a common theme in your research. And in the end, you have a very nice thesis with 3 excellent papers. I think you should be really proud of that. I mean, Erik and I are definitely proud, and for sure, Jean-Pierre would indeed be very proud of this work too. And so now you are in Amsterdam, so you had the opportunity to go to the VU for a postdoc. I think you managed to find your way around there. I hear your impressive running abilities are also getting brought up there. I hear even on Strava you're called a local legend of the Vondelpark. So I think you were finding your way around Amsterdam well there. And I also see in our Zoom meetings, when you don't have the virtual background on, sometimes still a painting shows up in the background. So you're also still painting. I mean, Amsterdam is of course a great city too, if you want to get inspired by paintings. And I think, I mean, at the VU, I'm pretty sure your colleagues and students appreciate having you around as much as we always have done so here in Maastricht. So let me round up by congratulating you, of course, also on behalf of Erik, with this wonderful achievement. And let me also congratulate all your family and friends who are watching. I hope some are watching from home in China, the live stream now. So they should also feel very proud of you. And of course, I wish you all the best in the future. Thank you.
Thank you.
Dear Dr. Lin, also on behalf of the Board of Deans, I congratulate you, your family and friends, and your supervisors with the honor you have acquired. And I would like to thank all members of the Review Committee for their contribution. I hereby declare this ceremony to be ended. Lots of success in your career.
Thank you.